Hello and welcome. This NYoSh Getting Started tutorial will demonstrate the NYoSh Workbench. You can obtain the Workbench from nyosh.compilerlab.org. When the web page shows on the right top side, you can access the early access preview currently available. When you click on this link, you will be offered a choice of 3 platforms for download. On Mac, you want to use a macOS platform. We have a Linux distribution and a multi-platform distribution that should also work on Windows machines. You just download the archive, and when it has downloaded, you decompress it and put the result under Applications in Mac. I'll show you here that I've done that a little bit before, and when you double click on the icon, this application should start. You get a splash screen here indicating the version number. This is an early access preview of the NYoSh Workbench. The build number that you will get may vary because we will be releasing new versions of NYoSh quickly until the final 1.0. When you start the NYoSh Workbench, you get a list of recent projects. I have a few, but your list may be empty on your machine. You just want to create a new project to get started, and in that case, I will do project 3 here. We'll accept the default. We will create a solution project. A solution project is a project in which you describe code expressed in the NYoSh and GobiWeb languages that are bundled with this workbench. We'll accept the default for the solution name. New solution will do fine, and we click OK here. When you do that, MPS is creating a project for us and starts the workbench. So this is a workbench. You have the logical view here where we see the project, we see the solution we have created in that project. We see the type of modules that are available. We will not look at that for now. To get started, the first thing you want to do is create a model inside the solution. A model will contain a number of concepts. So I'm just going to give it a name. I'm going to call it NewSolution.a and accept that. And I'm going to accept the default. So there are no dependencies and no used languages. And I go for it. OK. And now we have created this model that sits in a new solution. And the next step you want to do is to actually import languages into this solution. So you do this by right-clicking on the model name. You select New, and you go for Add Language Import. Here you will type a string of characters that will help you locate the language. In this dialog, you actually get access to the various languages that are part of NYoSh. And here we will pick the GobiWeb language. When you do that, the workbench prompts you and asks you whether you want to import also all the languages that NYoSh extends. Because this is convenient, you actually want to select import everything. So this now has configured the solution and the model, so you can right-click and go for Model Properties, and you should see under Used Languages, this tab here at the top, you should see all the different languages we have automatically imported. Those languages are extended by GobiWeb and are needed to run. Okay, so now that we have this, when you go back and you right-click and you go for New, you don't see the import languages anymore because we have done that. Instead, you get to see all the different languages that we have imported, including the GobiWeb language that we requested. Under GobiWeb, you have a number of concepts. Those are concepts of the language that we have imported. To get started here, we will create a resource with artifact script. That's a special kind of script that's used in GobiWeb to install an artifact on a compute node. So we click on this concept type here. Now get plugin resource with artifact script concept in the editor pane. You see here that this field ID is highlighted in red because it has not been entered yet. The field is mandatory. We can type here any kind of ID, we'll change it later. This ID has to map one of the plugin IDs in the plugin system that we're going to reference here. Let's look at the plugin system. So the plugin system is typically cloned from GitHub, our public GitHub repository. You should clone the experiment with MPS branch, or you can clone the entire repository and then switch to that branch. This branch is compatible with NYoSh. Eventually we will merge this back into master, but for the moment you need to use this branch. The URL of the repository is found directly from GitHub, and this is just the directory where we are going to put that clone of the Git repository. So we did the cloning already, and we went into this directory where the plugins are stored. You can see the usual plugin schema and artifacts config directory that make up our GobiWeb plugin repository. We are going to copy this path and enter it here. We cannot just copy this now. You see the red here. This indicates that we actually cannot enter text at this location. To understand why, you can use a feature of MPS that allows you to see what is available at a given location, and to do that you press Control space on a Mac, and this brings in auto-completion window with only one choice at this time, and you can accept this. Another way to do that is simply when you have a slot like that that needs an instance of a concept, you can press the return key, and this has the same effect. To delete the instance, you press delete, and you can play with that and do it a couple of times. Once you've created the instance, now we need a path at this location, and this is an actual string. So you can now paste the location of the directory. Okay, so this should allow you to have an ID here for your plugin. We know that the plugin is a resource, is of type resource, and the plugin root is located here. The information is needed in a NYoSh script, in a GobiWeb NYoSh script, because if we have all this information, we can automatically deploy the compiled script to the plugin directory, and that is very useful. So in order for that to work, we will need to actually provide an actual resource ID. So we go to the plugins resource directory and we see which plugins are available here. There should be one that is related to MPS perhaps. Here we go, sample resource with MPS. So we go to this directory and we look for the config file that is already provided. This file has an ID here, sample resource with MPS, that we are going to insert instead of the ID. So you see that you can copy and paste easily from the shell to within NYoSh, within the NYoSh Workbench that's based on MPS. The other part of the script is the script that I'm highlighting here. This bit is the actual executable script. It contains two entry points. The first one is from here to here, and this is a plugin install artifact entry point. This artifact entry point is called whenever GobiWeb needs to install an artifact that belongs to this resource. If you're familiar with the GobiWeb plugins, you will see that artifacts are defined here in the section of the config XML file, and each artifact comes as an ID. The first one is called first artifact, and second artifact in this sample. We will provide the installation code for the first artifact. To do this, we put the cursor at the very end of the statement, and we'll get back to that very soon, and we press return to create a new line. Once you've done that, the question is, what do we type here? This code should be executable. We can go back to using the completion, so we do control and space, and this brings up a list of statements that we can use at this location. You see that there is a very long list of statements because the entry point actually is a content. The body of the entry point can be expressed in base language extended with NYoSh statements. So you get almost all of Java statements. You can do for loops here. You can do all sorts of things. Int a equals 0, a less than 10, a plus plus, and here's a statement that would print hello world 10 times, for instance, if we wanted to do that here. Just to give you an idea that you can figure out very quickly with auto-completion what kind of statements are available. If you're looking for if, for instance, any statement that can be used and start with if, you have this statement that says if instance of, if a node. So this is another kind of statement. That's not Java. If you're looking for the if from the Java language, you should pick the first one that's from base language, as shown here. And if you accept that, then you get the usual base language Java-like construct. Okay, so we're not going to do an if statement at the moment. What we are going to do is to execute some installation code. So the first thing, perhaps, actually if is not a bad idea, so let's go back here. You notice that I'm using the undo redo feature of MPS. You get this feature by using with Apple Z, Shift Apple Z, and that executes or undoes and redoes statements, changes to the editor. So here what we're going to do is we're going to use the ID parameter to the entry point, and we are going to check whether this ID is equal to the first artifact ID. And if it is, then we will install that first artifact. Else, so here you see that I'm actually, you see how the auto-completion feature of MPS responds to different contexts. So because I'm placing the cursor at the end here of the if body, and I'm typing an if for the start of else, and I press control space, I now get the different possibilities at this location, and the menu is context dependent, so you really get only what you can use at that location in this context. So if it's not that, then let's copy the entire if again, and we are going to say second artifact. Okay. And if this is not the second artifact, then it is this is an error. ID must be one of the artifact must match one of the predefined artifact IDs. And we will fail with a return code of 1, which will cause a GobiWeb artifact installation feature to fail the installation of this artifact, so that next time it tries to install again, it requires this artifact, it will try to install it again. So for the first artifact, typically we often want to download software, and we can do this by executing some statements in NYoSh. So for instance, we have this special statement called execute that will take, and you see again I'm using the completion feature to learn what kind of commands are available in this context. You can see that we have operators, the semicolon, the 2 ampersands, the pipe operator, the pipe and the 2 pipes from Bash. They follow the exact same conventions. We also have a command, so I'm gonna go with that initially, and here you can just start to type a string like you would in bash. For instance, I'm going to say fetch command. Okay, and here I would like to add something. Sometimes projectional editors are a bit tricky to use, and to avoid problems, what we've done is we make extensive use of intentions. So intentions are context-dependent operations that become available when you click on this light bulb that appears depending on the context, and you can perhaps see that the options available vary. So for instance, here I have those two intention: insert JString component after this one or before this one, and we're going to use that. So for instance, I want to add a JString component. JString is a type of the expression I'm typing here after this one. So I'm pressing this, and now you see this as inserted a new component at the end of the JString. And when you use a completion, now you can add other things. So you can add a literal. Let's say you want to add a space right there, and now you want to add another component after that to say, okay, we're gonna fetch a URL perhaps. So I'm typing literal, and I'm gonna put a URL in there. Okay, so this is interesting, but you may notice that the text is actually still a string. So I have not actually. I would like to have variables for fetch command and for URL, but at the moment I only have one big literal here. So what I can do is I can bring an intention again, and I can choose the intention that says extract $var as variables. And when I click or accept this, I actually get two. I parse. I have parsed the literal into a variable reference, another literal, and a second URL reference. And you see, and what I just did here is put the cursor on top of URL and pressing Apple B. I'm navigating directly to the variable itself. I can do the same thing from fetch command, and Apple B will take you to the definition of the fetch command variable. Okay, so fetch command is actually we have a fetch command resource in GobiWeb, and the way you can discover that is so for instance we need access to the environment. So I'm gonna type $bracket like you would do in bash, and this gives me two possibilities. The first one is something more dynamic that we need. We're just gonna go with the second one that will read a single environment variable. And when we're there, we can use completion again, so control space. You're going to become very familiar with this when you work with NYoSh and MPS, because that's very, very useful. And here you get a long list of all the different variables that are available to this particular entry point. So what we're looking for, and you can type resources fetch URL script. That's the one I was looking for. When you do this, when you type actually the MPS NYoSh Workbench restricts the list of possibilities, and now we can choose the first one. And what we've just done is accept the suggestion, and now we have a reference to the value of this variable. So you see that within a NYoSh script, you get access to the GobiWeb environment very easily, and you can find the values of those variables very much like you would do in a bash script. So the URL, you typically know what this URL is. This is someplace.com/download/modifile.zip, let's say. So now this would very simply use a resource, the fetch script, to download the URL. And there is a third option to this script. We can add a component after this one that will be literal again. And we're gonna add a space, and we're gonna put a file name, and we're gonna use the same trick to parse again this var, and now we have again extracted this into another variable. So you can add my file.zip. Okay. You could rename, actually this feature is useful to rename files, so because you could use a wildcard here and then rename the result of the download to file.zip. Once you've got that, you typically want to execute a command that will unzip file name. You do the same, you use the intention to parse variables. What that does is it creates another variable, but since it's already defined, it's highlighted as already defined in scope. You can just delete it, and the Workbench will rebind this variable file name to the one that is already here. So by using the intention, what we've done is we've parsed the text to actually create a reference to a variable, and we have connected this to the existing variable. What you could have done the same thing a little bit more manually. So for instance here I'm going to go for command. I'm going to type this, and now I want to insert a gstring component after this one, and we will use completion to find the file name variable. And now we've done exactly the same thing without using the intention. We've connected the file name variable. We're using it inside the execute command. So after this command executes and succeeds, you will have decompress the content of file.zip, and assuming this succeeded, then we can continue with comments. And you would, for instance, copy some executable or compile and then copy some executable to the installation path, which is the second argument of this command. Here, this brief introduction should have shown you how you can very quickly combine commands here that fetch a URL, and this is coming from the Gobi Web environment into an NYoSh script. And so we've showed you intentions, we've showed you how to navigate to variables with command B here. That is very useful when you have fairly longer scripts. Another interesting feature is that errors are directly highlighted. You also get complete refactoring, so very trivially I can rename this variable, and you should notice here that this variable name is adjusted according to what I type in real time, and this would be true if you had multiple references inside the same script. This is a big advantage compared to using bash, where just inserting a character like this could break your program, but you wouldn't have any clue because you would only discover when the program executes. Okay, so last thing I want to show you is that you can compile this project, and so let's say here we go and we click rebuild. Alright, what happened here is that the NYoSh Workbench has compiled this to a Java class, and we actually get to see the Java class here in this new tab that was created when we recompiled. And you can actually browse and see, compare the two scripts. One is very short and succinct and very to the point, and the other one takes care of all the nitty-gritty details, is expressed in pure Java, and does exactly what you told us to do, and handles errors appropriately. Actually, to handle errors, an easy way to do that is to actually use another intention as a script, and you can add the Gobi Web error management by accepting the intention. What this just did is create a couple of concepts inside the model and when you double click on one concept, you get to see what it contains. So the Gobi Web default error management includes calling step slugging error handler whenever a step is executed or an error is encountered. And you can use Ctrl-B here to figure out what this does. And what this will do is actually call the step slugger helper to create a log file and assert true. In that case, it will actually fail and say indicate this message here that the step failed. This is highlighted in red, but we see that we can actually navigate to the class, so it should be all right when we compile. We can try to recompile again. All right. Whenever you compile, you will notice that a number of things happen. We create an install script that's required by Gobi Web for artifacts. We create a run model.sh on a plugin.jar. And if I go back to the plugin repository and the particular plugin directory we were looking at earlier, you can see that those files were copied indeed. And the plugin.jar is a code corresponding to the script that we have just created in NYoSh. So that if I look at the config file again and at the files that are defined here, I see that we have defined the run model script on the plugin classes, and we would be missing actually the plugin.jar file. So we would have to describe the plugin.jar file here so that this file gets copied to the compute server when the plugin is executed. But if you do that, this plugin will, you just need to rebuild in NYoSh to recompile and copy the plugin jar into the plugin home, and then it's ready for submission with the Gobi Web SDK. All right, this concludes our getting started tutorial, and I hope you found this informative and useful.